दें।
जी बिस्मिल्लाहिर्रहमानिर्रहीम. My name is Muhammad Asim Bilal, PhD student of Professor Dr. Muhammad Shabir. The topic of my seminar is Approximations of Pythagorean fuzzy sets over dual universes by soft binary relations. Layout of my presentation: Introduction to the topic, uh, Pythagorean fuzzy set, Pythagorean fuzzy soft set, approximations of Pythagorean fuzzy set by soft binary relations, Pythagorean fuzzy topology induced by soft reflexive relations, and application of proposed approach in decision making. Conclusion. References. Introduction. Soft set, fuzzy set, and rough set are significant methods to study the incompleteness and uncertainty in the information system. They have their own properties and superiorities, and they do have application in artificial intelligence, real life problems, and computer science. Zate initiated the idea of a fuzzy set in 1965, in which he portrayed fuzziness with proper mathematical language. A fuzzy set A is a mapping from universal set A to the interval 0, 1, where A of U for each U belongs to U represents the membership degree of U in A. In decision-making problems, different experts produce different evaluation results. Besides the membership degree in fuzzy set, the non-membership degree is also needed in many real-life situations. To this end, Atanaso set forward the idea of an intuitionistic fuzzy set. Intuitionistic fuzzy set, the relationship between AY, the membership degree, and AN of U, the non-membership degree of an element U in universal set U is AY of U plus AN of U must be less than or equal to 1. Due to its novelty, numerous researchers have worked in intuitionistic fuzzy set theory. However, since the relation AY of U plus AN of U is less than or equal to 1 is less satisfied by all the points below or on the line x plus y is equal to 1 in the first quadrant. So, intuitionistic fuzzy set cannot handle the situation when AY of U plus AN of U is greater than 1, provided AY of U, AN of U belongs to 0, 1 interval. This restriction confines the selection of AY of U and AN of U to form a triangular region as shown in the figure. To tackle this, Jaeger initiated the idea of Pythagorean fuzzy set in which AY of U membership degree and AN of U the non-membership degree must satisfy this relation. A square y plus a square n must be less than or equal to 1. Clearly, this relation describes the unit quarter circle in the first quadrant as shown in the figure. So one can describe the uncertainty associated with the membership degree and the non-membership degree in a better way than in the case of IFS, as PFS covers more points than were not covered by IFS as shown in the figure. Definition of Pythagorean fuzzy set. Let U be a non-empty universe. A Pythagorean fuzzy set A in the universe is a set having the form this, where AY is a mapping from U to 0, 1 interval and AN is a mapping from U to 0, 1 interval, uh, with the condition that A square y of U plus A square n of U is equal to R square of U for all U belongs to U, where R is again a mapping from U to 0, 1 interval. The value AY of U is called the degree of membership of U. The value AN of U is the degree of non-membership of U, and the value R of U is the strength of commitment at U. The pair AY of U, AN of U for any U is called a Pythagorean fuzzy number. Let R of U, theta of U be the polar coordinates of Pythagorean fuzzy number such that AY of U is equal to R of U cos theta of U and AN of U is equal to R of U sin theta of U. Then the function d from U to 0, 1 interval defined by U, d of U is equal to 1 minus 2 theta of U over pi is the direction of commitment at U. If theta of U is equal to pi by 2, then AY of U is equal to 0, AN of U is equal to R of U, which means the non-membership. Which means d of U direction is 0, and if theta of U is equal to 0, then AY of U is equal to R of U, AN of U is equal to 0, and the direction is 1, that is full membership. The collection of all Pythagorean fuzzy subsets of U is represented by PFS of U. Operations of Pythagorean fuzzy sets: consider A and B be two PFS in U, then the basic operations on PFS of U defined by Jaeger are as follows. A union is defined by supremum join operation, and intersection is defined by meet operation, and subset if a subset of B, if and only if a y of u is lesser or equal to a b y of u, and a n of u is greater or equal to b n of u for all u belongs to u. Equality relation holds if the membership and non-membership components are equal. Complement is simply the replacement of membership and non-membership degrees. The PFS 1U is equal to 1 0, and the PFS 0U is equal to 0 1, where 1 of u is equal to 1 and 0 of u is equal to 0 for all u belongs to u. Definition of score function. Yaga defined the score function f of a PFN as f of RA of u, theta of u is equal to 1 by 2 RA of u into 1 by 2 minus 2 theta over pi, where r square is equal to a square y plus a square u, and cos theta is equal to a y over RA. Let a and b be two a of u and p of u be two Pythagorean fuzzy numbers, and f of RA be and f of RB be the scores of a of u and b of u respectively. Then a is less than b if score function of a is less than score function of b. Score value of and a is greater than b if score value of a is greater than score value of b. A is equal to b if score value of a is equal to score value of b. Pythagorean fuzzy soft set. Peng et al. Proposed the idea of Pythagorean fuzzy soft set and discussed some operations on it. A pair FD is called Pythagorean fuzzy soft set over U if F is a mapping from D to Pythagorean fuzzy subsets of U such that F of E is a subset of parameters E. A Pythagorean soft set over U is a parameterized collection of Pythagorean fuzzy sets in U. For 2p Pythagorean fuzzy soft sets over common universe U, we say that F1 is a Pythagorean fuzzy soft set subset of F2 if D1 is subset of D2 and F1 of E is subset of F2 of E for all E belongs to D1. 2pFSS are said to be equal if F1 is F1 comma D1 is subset of F2 comma D2 and F2 D2. An intersection of PFSS over the common universe U are the HD and GD respectively, where H of E is equal to F1 of E union F2 of E, and G of E is equal to F1 of E intersection with F2 of E for all E belongs to D. A soft binary relation from U to W is a soft set over U cross W, that is F is a mapping from D to power set of U cross W, where D is a subset of the set of parameters. Obviously, if D is a parameterized collection of binary relation from U to W. Here, my work starts. Now we define the approximations of a Pythagorean fuzzy set. Let FD be a soft binary relation from U to W and A be a Pythagorean fuzzy set in W. We define lower approximations and upper approximations of A with respect to the after sets as follows. Lower approximation, the membership component of lower approximation of A and the non-membership component of lower approximation of A with respect to after sets. And upper approximation of the Pythagorean fuzzy set A membership component and the non-membership component are defined with respect to after sets. Where U f of E is equal to W is the W belongs to W such that U W belongs to f of E and is called the after set of U for all U belongs to U and E belongs to D. Lower approximation of A represents the degree to which U definitely has the property E. Lower approximation, the non-membership component represents the degree to which U probably does not have the property E. Similarly, the upper approximation, the membership component of upper approximation represents the degree to which U probably has the property E. This is the dual of above definition, that is, we define lower approximation and upper approximation of Pythagorean fuzzy set in U with respect to four sets. Upper approximation components where f of E into W is equal to U belongs to U such that U W belongs to f of E and is called the four set of W for W belongs to W and E belongs to D. Same situation here. The lower approximation, the membership component represents the degree to which W definitely has the property. The non-membership component represents the degree to which W probably does not have the property E. The membership component of upper approximation represents the degree to which W probably has the property E. To illustrate the above ideas, we have an example. Suppose a student wants to buy new shoes. Let U is equal to set of all available shoe designs. W is the represents the colors of all design, and the set of attribute means the set of stores near his house. We define a soft relation f from D to power set of U cross W by f of E1, f of E2 represent the relation between designs and colors available at stores E1 and E2 respectively. Let Pythagorean sets A and B on W and U respectively, where A represents the preference given by the student of colors, and B represents the preference of design given by the student, and are defined by A is equal to this and B is equal to this Pythagorean fuzzy sets. Table 1 shows that lower and upper approximations of A with respect to after sets DIF of AJ are two Pythagorean fuzzy sets on U. Similarly, table 2 shows that the lower approximation and upper approximation of Pythagorean fuzzy set B with respect to fourths are two Pythagorean fuzzy sets on W. Let FD be a soft binary relation from U to W, that is F is mapping from for any three Pythagorean fuzzy sets. We have the following results. If A1 is subset of A2, then lower approximation of A1 is subset of lower approximation of A2. If A1 is subset of A2, then upper approximation of A1 is subset of upper approximation of A2. If the third property, intersection of lower approximations of A1 and A2 is equal to lower approximation of A1 intersection A2. Fourth property of A1 intersection A2 is subset of the intersection of upper approximation of A1 and A2. Fifth property, lower approximation of A1 union E2 is superset of the union of lower approximations of A1 and A2. Sixth property, union of upper approximation of A1 and A2 is equal to upper approximation of A1 union A2. Seventh is lower approximation, and the eighth property is the complement property, that is lower approximation of A is equal to the complement A is equal to of approximation of A complement, and similarly the second property. Last property is with respect to the null set. Null Pythagorean fuzzy set is equal to null set, and similarly the upper approximation. The following example shows same results hold with if we take with respect to the after sets. The following example shows that the equality does not hold in parts 4 and 5 of above theorem. Utilizing the information given in example 1, define two Pythagorean fuzzy sets A1 and A2 on W by this, then A1 intersection A2 is equal to this, and A1 union A2 is equal to this. Observing table 3, we can easily see that the equality does not hold two Pythagorean fuzzy sets. Similarly, table 2 shows that it with respect to intersection. Theorem, let F1, F2 be two soft binary relation from U to W such that F1 is subset of F2, and then for any Pythagorean fuzzy set A, F the lower approximation of A is with respect to the soft binary relation F1 is subset of lower approximation of A with respect to soft binary relation, and similarly the second result. Let F1 and F2 relations, same result of with respect to after sets. Let F1 and F2 be two soft binary relation from U to W, then for any A belongs to P Pythagorean fuzzy set, the following are true. Similarly, we have the following with respect to after sets. P be a soft binary relation from U to W and AI be the collection of Pythagorean fuzzy sets defined on W, then the following hold. Dual with respect to four after sets, the results are also hold. Pythagorean fuzzy topology is induced by soft binary relation, reflexive relation. Olgan presented the idea of Pythagorean fuzzy topology as continuity between two Pythagorean fuzzy topological spaces. Here we introduce kinds of topologies induced by a soft reflexive relation. First definition of Pythagorean fuzzy topology: a family A subsets of Pythagorean fuzzy subsets of U of called a Pythagorean fuzzy topology on U if it satisfies 0, 1 belongs to A1 intersection A2 belongs to A for all A1, A2, and the union AI belongs to A for all AI belongs to A, and I is an indexing set element. I belongs to an indexing set. If A is a Pythagorean fuzzy topology, then the pair UA is called a Pythagorean fuzzy topological space. The elements of U are called Pythagorean fuzzy open sets. Theorem, this is the new definition of Pythagorean fuzzy topology induced by soft binary relation. If FD is a soft reflexive relation, then ta E defined by this A belongs to a Pythagorean fuzzy set of U such that lower approximation of A is equal to A, then is called a Pythagorean fuzzy topology on U for each E belongs to D. Similarly, the relation holds with respect to after sets. The dual of above result holds. Application of proposed approach in decision making. A soft binary relation is a parameterized family of binary relation on a universe, so that parameterized family really helpful in decision making approaches. It is a generalization of ordinary binary relation on a set. In rough set theory, rough approximation just address single binary relation. In any case, a rough approximation in the sense of soft binary relation can deal with different binary relations. Pollack's rough set theory can be seen as an uncommon instance of soft rough sets because of soft binary relations. Kamal and Shabir defined lower and upper approximations of a fuzzy set in semi-groups using soft binary relation with an application to a real-life problem. Hussain et al. Introduced Pythagorean fuzzy soft rough set and soft rough Pythagorean fuzzy set and gave a method for decision making based on soft binary relations. In this work, we propose another way to deal with decision making problem based on a Pythagorean fuzzy soft rough set theory by soft binary relation and extend the existing approaches presented by Kamal and Shabir and Hussain et al. This approach will use the data information provided by the decision-making problem only and will not require any extra information by decision makers other way. So it can avoid the effect of subjective information on the decision results. Therefore, the outcomes could be more objective and could avoid the paradox results for the same decision problem. As the lower and upper approximations are the two most close to the approximated set of universe, therefore we obtain the two most close values with respect to after sets to the decision alternative ui of the universe by the Pythagorean fuzzy soft lower and upper approximations of Pythagorean fuzzy set A. So we define the choice value delta I for the decision alternative ui on the universe with respect to the after set using the score value of this. So delta I is defined in this way. Application here comes for of the following steps. Step one is the computation of lower Pythagorean fuzzy soft set approximation and upper Pythagorean fuzzy sort approximation of a Pythagorean fuzzy set with respect to the after sets. Step two, compute lower score function. Step three is the calculation of the score number, the choice value delta I. The step four, the best decision is where for which delta m is maximum, and the worst decision is for which delta m is minimum. If m has more than m as the best or worst alternative. Algorithm 2, which is simply the dual of above algorithm with respect to 4 sets. Example to illustrate the above algorithm. Here we show the steps of decision making method proposed in this paper by using an example for the selection of a car. For example, we take Ministry of Foreign Affairs Pakistan needs to purchase a car for the reception of international guests. Foreign Minister is provided with the following list of models and colors of cars available in 3 different showrooms in Islamabad, Pakistan. Let U denotes the set of available car models, W denote the set of available colors of car, and D denote the set of parameters, that is the set of car showrooms in Islamabad. We define a soft relation F from D to power set of U cross W by this F of E1 and F of E2. Similarly, F of E3. Which represent the relation between models and colors available at showrooms E1, E2, E3 respectively. Minister gives the preference for the models and colors in the form of 2 Pythagorean fuzzy sets. Let A and B be 2 Pythagorean fuzzy sets in W and U respectively, where A represents the preference of colors represented by the colors, and B represent the colors preference of models by the respected minister, such that A is equal to this and B is equal to approximations of Pythagorean fuzzy set A with respect to after sets. This table shows. Table 6 shows approximations of Pythagorean fuzzy set B with respect to 4 sets. Table 7 shows the delta I using the score function. Table 8 shows choice values with respect. Table 5 and 6 represent the approximations of A and B. Moving on to step 3 of algorithm 1 and 2, we calculate the delta I. It is clear from table 7 that maximum choice value is delta 4, that is 3.7, scored by the model M4. Thus, the decision goes in the favor of model 4. Likewise, from table 8, the maximum choice value is delta dash 3, scored by the color 3 C3, so the decision is in the favor of color C3. Thus, the most ideal choices are model M4 and NC, and foreign minister will select it, and the best showroom is E1. Conclusion: rough set, soft set, intuitionistic fuzzy set, and Pythagorean fuzzy set are all exceptionally significant mathematical tools for managing uncertain circumstances. PFS generalizes the intuitionistic fuzzy set. In this manuscript, the notion approximation of Pythagorean is presented using soft binary relation. We presented some basic ideas, properties, related examples. Likewise, we define 2 kinds of Pythagorean fuzzy topologies induced by soft reflexive relations. Nonetheless, further work should be done to explore the theoretical features as well as many practical implementations. Modification, the legitimacy and effectiveness of proposed approach are checked by applying it to a real-life problem based on Pythagorean fuzzy set by analyzing the advantages and disadvantages. The decision steps and algorithm of decision method were also given. This method can give an object decision result with the data information owned by the decision problem only. Operators defined by Wang et al. Can be used for ranking the Pythagorean fuzzy sets based on soft binary relations. Further, using the ideas presented by Zhang, and an approach can be established for two-sided matching decision making with multi-granulation Pythagorean fuzzy linguistic terms sets. With the motivation of concrete ideas presented in this paper, an investigation of theoretical parts of these generalized ideas is most important and needs more consideration. Besides, the axiomatization of approximation operators is an interesting issue to be investigated. References. Thank you.
अच्छा, आंटी, आपका जो काम है ये लाइक सबमिटेड है सॉर्ट ऑफ, या आपने पब्लिश
मैडम
कर लिया है?
ये पब्लिश्ड है मैडम।
अच्छा, चलें।